Hello, and welcome to my presentation on the evolution of OT systems management, or what we call OTSM. I hope to walk you through some interesting topics about why we think ICS security is better suited when we start to talk about the end systems, endpoints, where the risk actually resides. To help us through that, I'm going to start with an introduction to myself, as well as the organization I work for. A little bit of a talk about the current situation, why we think this is a challenge in OT today. A little bit about what the market has tried to do, what we've seen for different trends and how that does or doesn't work, sort of an assessment of where we stand today, and then maybe some recommended changes in a focus and our approach to how we want to manage these endpoints. I want to talk a little bit about the results we get, and then share some conclusions, and hopefully this is worth the while, and I look forward to sharing some ideas with you today. First and foremost, Verve as a company is who I work for, Verve Industrial Protection. We were founded 30 years ago as a systems integrator in the power sector. So we've done over 30 years of systems integration, DCS programming, PLC upgrades. We understand the OT world. We were first and foremost automation engineers that have grown into modern day challenges around OT, such as security. And the security portion of our history has actually been around for almost half, so 13 of those 30 years. Everything I've talked to you about today relative to technology and possibilities in the OT space has been running and proven in the OT space for over 13 years. Today, we've evolved into a fully integrated solution provider. We realize that, as much as some people want to be a services company or software company, security is a program. And in the OT world, it's very complex, lots of moving parts, and scarce resources to be able to make it work. So the better we can scale people and knowledge, the better off we are. And that's why we have a turnkey capability in helping clients either from the planning and management phase into the actual deployment and eventually maintenance. I myself have been actually doing ICS security consulting, program design, gap assessment, remediation projects, etc., for almost 20 years now. As you can see there, I worked for a company called Matricon, did a lot of OPC connectivity, a lot of alarm management, loop tuning, etc. We eventually got bought by Honeywell, which has afforded me the opportunity to see not only all size and shape of organization around the world through Honeywell, but as you can see in the second bullet, the emergence of regulation and how you would actually try to apply rigorous or consistent controls across an entire industry. From that experience, I realized that everybody has a similar challenge regardless of their industry. And so the best thing we can do is help to manage the entire program, vendor agnostic, as well as a holistic program. Simply treating certain symptoms within the overall program is interesting. It is short little gains and wins, but when you're looking at the overall ongoing maintenance, you need a much more programmatic approach. So why would we think endpoint management is an issue? Well, there's numerous stats that show to the risk typically comes into OT through IT-looking systems. But why don't we take it a different angle? The CyberSeek job database, which tracks the millions of jobs that are unfulfilled in security. And if you look, the top three, and arguably the fourth with the govern and oversee of systems, these all say things around management and patch management, configuration management, etc. And they make up at least 60 to 75% of the jobs that are out there. So it's not just that my theory is that we need to be doing something about the endpoints. This is borne out by the typical job offerings in the market as well. And really only a smaller amount are the monitoring portion. And the reason I point that out is twofold. If we really want to make a step change in security, we need to go to where the risk is. And the second is that I think we've got the passive and the perimeter monitoring, the network intrusion detection and the perimeter protection really well handled and fairly well established. It's time to turn our attentions to the next generation of security risk, and that means the endpoint. Oh, what are the challenges though? Well, we often hear you can't patch. Devices are too sensitive, the process is too critical. We can't automate vulnerability assessments. Everybody wants to know first, what do they have and how is it configured? And so the idea is that if I at least have a list of IP addresses and known vulnerabilities, I'm a starting point for my knowledge. Well, I hope to show you that a cursory understanding of inventory, especially in OT, is very short-sighted. What you really need is a complex understanding of the assets, their context in the operational environment, and their other compensating controls, which of course we'll get into. It's difficult to inventory multiple segments, islanded subnets, SCADA distribution for pipeline transmission, et cetera, means, very challenging bandwidth issues. And most importantly, there's not enough people. Operating teams are stretched to the limit, just trying to keep systems and facilities online, maximizing output, minimizing downtime. There's not a lot of extra bodies to run around and do the nice to do things like patching and system hardening. And most important, everybody says you can't use an agent. You have to be very careful and stay to the perimeter and don't touch anything. Well, really, that's a lot of can'ts. And I want to challenge almost every single one of these. I often tell anyone in IT, I can help the OT people get to where they need to. I'm probably just going to take a slightly different path and maybe use some different technology. The idea is to get as close as possible and to collaborate to get there. So what does that mean in the current situation? Well, like I said, perimeter security has had plenty of attention. There are significantly powerful and effective tools in the passive anomaly detection space, in the perimeter detection in the next generation firewalls, in SOCs, and the emergence of threat hunting and machine learning. And that's great. But the problem is we need to get inside the firewall. We need to get inside the perimeter. And usually the two biggest questions are, can you give me, like I said, an inventory and what vulnerabilities are present on there? Well, the result many people have done in lieu of, in the face of the pressure to do those two things, inventory and vulnerabilities, without wanting to touch OT, is they've gone to yet another sort of perimeter thing, and that's the passive anomaly detection. Why? Well, because they say it's non-invasive. And the truly passive that sit and listen are non-invasive. However, ask your passive anomaly vendor, they will tell you they either have or are developing active components as well, because they know they need more information. It can provide risk and a little bit of alerting. They are built for anomaly detection. They are a fire alarm. They are there to tell you when something's gone wrong. Now, as a byproduct, they get an inventory by seeing what's talking to what and seeing deviations to that communication. That's the premise upon which they build their machine learning. That means that as a byproduct, they have an inventory, but there's some challenges to that inventory. If they're not listening on all segments, if the information that you really need isn't being transmitted, you're missing key components and large swaths of information. And so I kind of joke, it's like the emperor's new clothes. We think it's fantastic and wonderful and perfect fit, but it's not. It's a good start. It does do some of the basic requirements, but it's not exhaustive. Now, why is that a problem? Well, let me share this with you. This is taken from the NIST CSF, National Institute of Standards and Technology, recommendation around patch urgency. Now, we talked about being able to patch or not. You can't always patch. Maybe the vendor says you can. Maybe they say you can't. Maybe they say you can, but it needs a reboot, so you're not going to do that to the next outage. And some of you run for weeks or months, if not years. And so we need to be able to look beyond the patch. This is what I call compensating controls, or plan B, plan C, et cetera. And so when you look at the normal thought process through identification of vulnerabilities and patches, first thing we do is, does it actually affect us? And already we're going to need to know some information, both about the patch, but also about the environment in which this patch may be going into, to see if it lines up with any of my assets. If not, we ignore, right? Which isn't great because there's still risk, but it's an understandable path. If we do have an issue with it affecting ICS, then the very next thing we ask is, can we find a workaround? Notice that we're not simply going identify patch and patch, right? There's a long stretch between patch and identification and deployment. And on we go through this. Is there a workaround? Is the operational need greater than the risk? Understanding the risk, understanding the asset, understanding its context. I can't simply tell you that there is a patch, Bluekeep, for example, and you know that it's present on or needed on many of your systems. Well, which ones? In which importance? Which order? At what urgency? All of those have to come from the analysis, and the analysis is going to come from your inventory, but not just the IP and MAC address, and not just a subset of the assets, and not just a subset of the data about the assets. So this is really what drives meaningful risk reduction in OT. So what do you really need? You actually need what we call OT context. A simple inventory IP and MAC address is not enough. It never will be. It's going to fall very short, and you're going to be disappointed and left with gaps. What you really need is a deep asset inventory. Yes, IP, MAC, and operating system, but you also need installed software. and all users, not just currently logged in, which WMI gets you, not the ones that are currently actively logging in from point to point and being packed up by passive. What about the dormant administrative accounts, the ones that were built by your OEM during FAT and SAT? What about the one that your super troubleshooting guy built as a backdoor to most of his systems just to make sure you can get into them? What about your user review policy? If your employees depart, do their accounts get wiped out from all systems? And so the more we can get about the information about the asset, the better off we'll be. We had one client did an internal audit recently and found 47 administrative level accounts on endpoints that belonged to no longer employed people. They had departed the company. And so there's 47 exploitable accounts on those systems in various parts of their critical environment that could be exploitable by a virus, malware, or malicious insider. So what do we need? We need the ability to get, of course, hardware inventory and software as well. Software that's installed but not transmitting like the rest of the Office stack when all you needed was Excel for ladder logic is a significant risk. We need to know the vulnerabilities. We need to know the patches that apply to those vulnerabilities. We need to know how the device is configured if we can't apply the patch, because again, we're going to come to compensating controls. Users and accounts, what are the status of other security protections, backup, antivirus, and your network segmentation? Do you have other stopgaps in place, and what is their current status? We often put in our technology and see that while there are well-intentioned firewall rules, the firewall rules themselves may not work, or some devices may be dual homed around it. And so you find all sorts of information about the asset that you don't simply get from IP and MAC. And finally, the asset's context. Not all assets are created equal in an OT space. I'm not going to run out and do full-blown backup, restoration, duplicate, redundant systems for every single device. There are those that fit that category, but there are those we can live without for either a day, a week, a month, maybe a few hours. Those are going to have a different response priority. But until you understand the totality, or what we call the 360-degree view of the asset, you're not going to have that much of it, that informed of a decision. So what do we recommend? We recommend that information from the assets, all assets as much as possible, and we advocate going directly to the asset, not hoping that the asset's going to tell me something passively on a wire or through a packet inspection, but actually going to the endpoint and profiling it. When I go to the endpoint with an agent, I can get 1,000 characteristics of the asset. When I go to an embedded device like a PLC or a relay, I can get serial number, firmware, hardware every time. That's where we start to really build that inventory. And we recommend that it's automated as well, because these things actually do change more than you think. We want asset context, as I mentioned. So it's great that I have a whole bunch of Windows devices, but which ones are domain controllers, which ones are engineering stations, which ones are redundant file servers or backup storage. The next part about once you built the inventory and are building a programmatic approach is let's switch from reading and monitoring to acting and writing. So if you can take actions, deploying patches, or when you can't deploy a patch, potentially applying different security controls like disabling services or uninstalling software. This is where we really get into further into that decision tree about to patch or not to patch, but also how to reduce risk. And all of it stems from the endpoint and what we know about it and what we can or can't do to it. You, of course, need the alerting and reporting on top. We want to be going through and hardening and managing our endpoints, but we need to be able to keep an eye on it. So if you build this sort of view with these different topics and context into it, and you automate the refresh of that, you have gone from not knowing what you have and how it's configured to having a real-time feedback loop, a very comprehensive understanding of your systems, how they're behaving, how they're being treated, and where your risk is at. Now, when you architect it, it's going to look what we call think global and act local. Now, I have another session tomorrow on exactly this, so I'm going to save all the thunder for that one. But the premise is, in response to the fact that there's a lack of staff, this sort of automated environment that I'm talking about can allow for you to aggregate all of the data automatically from a number of your facilities into a single central location, or multiple, depending on your architecture and your geography. The idea being that you push the data upwards. And if you're able to aggregate multiple sites into a single view, when something like Bluekeep comes out, you and your organization can have a very minimal amount of people actually analyze how big of an impact that has across your organization. You are then able to design remediations, whether that's the patch, on systems that are redundant or can be tested or taken care of or don't need rebooting, or whether that's providing compensating controls. In the case of Bluekeep, maybe simply disabling remote desktop or disabling the guest account. But you can build that design and do that research once and share it across the entirety of your organization. You don't have individual silos and different units at different locations all running around doing their own things at their own pace. You have the ability, once you build this endpoint view and this automated data collection to give you that aggregate view, to be really, really efficient in your actions, your protections, and your risk reduction measures. So what are the benefits? Endpoint Perspective provides live context, right? We have a client that can look at any one of 6,000 assets in 57 countries around the world from a central location. And that data updates every 15 minutes globally. The near real-time view then provides you with the opportunity to accurately assess your needs. Again, Bluekeep comes out, we don't simply start patching at the top of the alphabet, right? We need to be able to figure out what we need to do in what order and what's an acceptable follow-on plan or secondary security measures. By having the automated feedback as you make progress, your progress is reported, your improvements are reflected in your dashboard. And if something comes the other way, like the next patch, you instantly see where it lights you up in your facility. It's a significant game changer in terms of risk reduction by going to the endpoints, pulling this data together, and addressing security by actually managing and touching and handling those endpoints. Remember, been done safely in OT for 13 years now. Now, to prove my point, I wanted to bring a few different case studies. And this is really just trying to show you the value you get from actually spending the time and money to pull the data from the asset and provide context. The first one is inventory. What I'm showing you here are a couple of different views that might be of help to understand basic inventory. Along the bottom, I've got the concept of multiple sites, 3 different sites. And I've got the data or the asset type by control function. So when, again, we're talking about maybe doing a test on a patching system, you don't have to have a whole offline system, don't have to have a whole test bed in a lab. I could simply say, well, it's pretty good to test domain controllers because they're usually redundant. And they can reboot because there's a spare. Maybe I'll start my testing on domain controllers. We certainly don't want to start with operator HMIs. Maybe we start with historians. The idea is I get a much better idea as to what I have in what area and where I want to start and what I want to protect and help to build my priority. In addition to that, you're going to want to know the software. So I'm showing you here the ability to show software installation by date, software that we want to keep an eye on. We call this questionable software. IP scanner, team viewer, things like that that are potentially bypassing firewalls, but also different unique versions of different software. One of the anecdotes I have is a client that was able to identify and remove 150 copies of an older exploitable piece of software by simply going to this dashboard and typing the name in and seeing instantly across 6 sites how many they had. What about inventory of your users? Here I'm showing inactive user accounts, so people that have not logged in for over 180 days. I'm also showing the impact of assets. So I've got some high impact assets here. I know these graphs are a bit small, but I'll share the slides after. I've got a number of my devices that are high impact to operations that have a number of inactive user accounts. That's a pretty telling thing that you probably want to fix. Inventory can also take the view of how it's placed in the network. So carrying on through the inventory, what if I wanted to know from the previous slide, the domain controllers that were only in zone 3.5 of the Purdue model. A domain controller further down in zone 3 or 2 is maybe a proprietary one owned by the OEM as a very specific function, may not be as robust a starting point to test patching or system hardening or other controls on, but I could filter domain controller versus DMZ. Then over here, the asset impact, if it's a low impact asset, I've now gone to my probably safest device in my fleet to be testing on. And if I clicked on those 3 to filter, I would then drive right down into very specific and safe test beds and sandboxes. This is the view that you start to get if you take the time to build the endpoint automated inventory, but with context as well. You could also see how these devices are connected to one another, or you could see, again, a risk score. Now, this is where we work with clients to take a number of these indicators and say, if you are a high impact asset and you have critical risk from the vulnerability database, and you don't have your backup, a recent backup, you get a high score, and that puts you in the critical category. If you fix one or two of those, that changes it. So you have a dynamic ability to measure within your data as well. Okay, so once you have inventory, though, let's flip to vulnerabilities. And again, trying to build on the theme of the more data and the context we have around the asset, the better we are at that decision tree I showed you earlier to not only understand your assets, but be able to react in a proper and appropriate way. So the step one that everybody wants is to map vulnerabilities. Well, here is a mapping of the entire national vulnerability database against one of those comprehensive inventories I was just showing you. The same 3 sites we were looking at. Now we're seeing per site by criticality. The dark red is a critical risk, and the number of them at that site versus low or a medium or high. We can also see the individual devices that have a cumulative score that we really want to be worried about. But the real value, because I can show any of you hundreds or thousands of risks in any one of your environments, the value to you is helping you filter that out from the noise to what I need to be worried about. And so here what we've done is taken this view and added filters. I've filtered simply on the critical risks, so only critical vulnerabilities. I've added the impact ranking of the asset, which we get from operations, maybe a HazOps or a safety environment, a safety rating. So we've got high impact assets, things that really affect operations significantly, that have critical risk. But I'm also pulling in the ones of those devices that failed their last backup and that don't have whitelisting in enforcement mode. So you can very quickly go from noise to the ones that you really need to worry about. Critical risk on a high impact asset that doesn't have a safety net in the form of a backup, and whitelisting isn't locked down yet. That's exactly what you can filter on to turn noise into very accurate and targeted risk reduction. The next slide. Once we've got vulnerabilities and inventory, next we go to patching, right? Now, being able to understand all patches by bug fix, critical update, workaround, etc., and the release date, I really start to understand the mapping of first understand what I have, make sure it's exhaustive and automated update and very, very detailed information. Then I bring in the vulnerabilities, and now I see what remediations I have available to me in the form of patches. Now, this raw number, large number of assets, hundreds and thousands of patches missing, again, can be noise. That's why we offer the filter. Over here, I've shown an example of taking a vendor's approved list, and this is showing, again, very small, but I'll share the slides. This is a sample GE list from November of 2020 that they approved. So to be able to take all of your assets and filter them to what the vendor approves, and now I've got 71, of which 8 are critical, my job is now only to review and figure out how I'm going to manage 8 critical risks on however many assets there are, but I'm not trying to look at hundreds or thousands like these numbers represent over here. The last line of defense, obviously after whitelisting and backup, but in terms of going to the endpoint, well, if I can't apply the patch, can I harden the system? Can I change some configuration or service or registry settings? And that's what we're showing here. Once you deploy this automated technology, if you're pulling the data back correctly and pulling back the amount and type of data you need, you can then measure both hardware and software against, I think we have about 46 different controls here that are measuring best practice for system hardening and least privilege. So disabling the guest account, renaming the administrator account, setting the lockout duration, etc., along a number of parameters as recommended by best practice. And now I can start to pull individual levers downstream from a patch. So as you can see, we have this iterative, first step, second step, third step for managing the endpoint. Notice we haven't talked about perimeter, we haven't talked about monitoring, detection, machine learning, or anything. We're now being proactive in helping to reduce risk by understanding, analyzing, and then proactively managing and tuning my endpoints. We can do this for hardware and software. We can also do this for network gear. There's a number of standards that talk about how network and firewalls and routers, et cetera, should be configured. And understanding not only how you're doing relative to best practice, but within here, again, on a particular risk, to be able to turn on or off certain services is a significant improvement. So let me show you what that looks like live, okay? We have a client that took this approach and they wanted to say, look, everything that's in there is important. I just don't want to know inventory. I don't want to just know vulnerability. I want to know all those things. you touched upon, the network communication, the presence and the location in different zones. And so what they're doing is they're taking this automated asset inventory, bringing it up to that central reporting, and then they're using a best practice guideline to look at multiple measures or indicators of risk. It's like taking the traditional annual paper-based assessment that you hire an outside firm to do, and they write and they hand you the paper and then you're done. And it immediately ages, and you're turning it into, much like OT, a real-time feedback loop. You all have process in the environment. You're going to be looking at a trend to see how your production facility is doing, or your different inputs and outputs are going. This is almost the same thing. So the client profile is a global manufacturing company. They deploy endpoint management with automated reporting and actionability, all the three things I've talked about. So automated inventory, central reporting with the ability to measure multiple indicators and dive into different filters, but also that same ability to act, so to deploy the patches and harden the systems, et cetera. And then they wanted to assess what they found. They put all the technology in, turned on all the dashboards, and said, okay, what do we have here? Some of the major findings you can see on the slide here. There were 400 devices not patched for NotPetya or WannaCry. There were 5 dual-homed machines. 4 of them were running TeamViewer. So they had a network segmentation project and policy, and they even had a firewall, but they had devices bypassing it. As I mentioned, there were 47 administrative accounts. The problem was not only were there the active accounts were allowed, but they missed the setting in the password policy, which made them change the password. So for 4 years, they were using the same password. Just moving along, some of the findings, I won't read through all of them. But the endpoint can even tell you about how the network is doing. We can architect the network, and unless we check the rules and actually test, we're never going to find it. So as you can see, we found architecture findings, endpoint, very significant high-risk findings. We found critical risk relative to access control, remote access, as well as policies and procedures. A lot of violation of what they thought they were doing and what they should be doing. They measured the one site against others. So some of the findings here are of one of the individual sites. These 20 controls are the CSC 20, and the sites themselves are the score that each site got relative to that. We don't need to go into exhaustive detail, but I just want to show the depth and breadth of this view. They were able to see that there were default credentials on networking equipment, easily guessed passwords, multiple shared logins, several inactive accounts, but I'm sure you know that all these exist in your environment. Although I bet you didn't know that we could exactly point to which account on which system where. And that's the difference that this sort of approach takes. Remote access, huge thing with COVID and people working remotely. The ability to look at who's logging into which systems, to harden those systems, to limit people's access to certain jump points that are much more controlled and are much stripped down in terms of what's on them. And keeping logs for when things are changed and what they're doing is a significant change from simply turning on remote desktop and having backdoor modems, which many facilities have. And finally, my favorite, we're able to see, for example, firewall rules not limiting traffic. We're seeing communication between subnets that shouldn't be allowed, at least on certain ports. We can also see multiple devices with dual home to log traffic by port and really start to see how this environment is behaving within these parameters as well. So that was a fair amount to cover. I wanted to leave a few highlights here. An automated endpoint approach, that aggregated view, and again, please come see my speech tomorrow on Think Global and Act Local. That's actually using this type of infrastructure to build into actual use cases, both proactive and reactive. It turns you to being in charge of things rather than my friend up here trying to keep up with what pops up and when and where. Automation is your friend. The more we can gather automatically, the more context we can provide. I don't just want IP and MAC. I can tell you a whole bunch of IP addresses. If it's a redundant file share system versus a critical HMI, I have to know that context. And these environments are more dynamic than you think. We need to update and refresh as we go. And most importantly, we need to take action. All of the alerting and monitoring in the world is useless if we have no tools to correct the risk and avoid the same incident next time. Tie those multiple tools and views together, you'll have a much better fighting chance of being able to handle this. And I think you'll find that you make a step change in improvement. I think you saw the one slide. One of our clients saw a 70% reduction in manual maintenance and therefore an increase in visibility and risk reduction. 70% over current manual efforts. That's it for me right now. I really appreciate your time. I hope it was worth your while. My name is Rick. You can see on the slide there how to get a hold of me. Be happy to talk about how we can help your organization or field any questions. Once again, thank you for coming. I hope it was worth your time. Have a great day.